So again, as I stated before, the first three questions were pretty quick. That last question, which involved graphing your tangent function, was a bit more tedious. So let's jump into it. We have question one, find the exact value of the 6 trigonometric ratios, which I did the liberty of giving you all 6 off to the side here. In a right triangle that has a hypotenuse of length 8 and the opposite side to our angle theta is of length 7. And so let's draw out our right triangle. We have our angle theta. We're given that the hypotenuse is 8, and we're given that the length opposite our angle is 7. We're utilizing our SOHCAHTOA here. And so our sine of theta, is our opposite over our hypotenuse. So opposite, 7 over our hypotenuse. I believe almost every single student got at least this part correct, because it was just given in the problem. Everything else you sort of needed to utilize Pythagorean theorem and then solve. So what is Pythagorean theorem? Our a squared plus b squared equals c squared. And we are missing our side. We'll call that a since it's a leg. So we have a squared plus 7 squared equals 8 squared. Simplify and we get 8 squared is 64 minus 7 squared is 49. And so we get our a is equal to the square root of 15. Now that we know this adjacent side to our angle theta, we can figure out our cosine, which is adjacent square root of 15 over our hypotenuse, 8. Our tangent is our opposite, which is 7 over our square root of 15. But we can never have square roots in the denominator, so you need to rationalize in order to get full credit. And so your answer should have been 7 square root of 15 over 15. And now the last 3 are just the reciprocals. So we literally just flip the numerators and denominators for our previous 3. Cosecant is the reciprocal of sine. So flip 7 over 8, you get 8 over 7. Secant is the reciprocal of cosine. So flip square root of 15 over 8, you get 8 over square root of 15, but you have to rationalize that denominator. So multiply it by that fancy form of 1, and you get 8 square root of 15 over 15. And then last but not least, we have cotangent, which is the reciprocal of tangent. We already rationalized tangent, so let's just look at our initial answer and just flip that so we don't have to do any simplification. We just get square root of 15 over 7, and we're done. Any questions on this one? Again, mark it up if you did make any mistakes. And now we're going to move on to our question 2, which we want to find the exact value of cosine 7 pi over 4. Well, we know that a full revolution around a circle is 2 pi, also known as 8 pi over 4, which means 7 pi over 4 gets quite close, goes all the way around, and then it stops right about here. This is our terminal side, leaving us with a reference angle of pi over 4. So if our theta equals 7 pi over 4, then our reference angle we'll call theta hat is pi over 4. Another thing you need to be mindful of is the fact that we are in our fourth quadrant, which by our acronym, All Students Take Calculus, this tells us that all of our cosine related functions are positive. So we don't have to incorporate any negatives here. And so what we can do is now we can create our equivalence relation. Cosine of 7 pi over 4 is the same as just cosine of pi over 4. And pi over 4, if you are more comfortable with degrees, is just 45 degrees. And what is cosine of 45? We need to calculate this. That's just the square root of 2 over 2. And we're done. Let's now go ahead and move to our question 3, which was just an identification problem. We're given our function f of x is equal to 10 sine of 0.5x is the same as just 1/2 x. I just particularly like fractions. And if you wanted to write that general form dealing with trigonometric functions and their transformations, you could. That's just keep it in terms of sine, b in parentheses x minus c over b, and then plus d, our vertical shift or our equation of our midline, which will help us in question 4 in a moment. And so now we can easily identify our amplitude. Our amplitude is our absolute value of A. Which is just the absolute value of 10, which gives us 10. And they also ask us to calculate our period. And so our period when we're dealing with sine functions or cosine functions is 2 pi over the absolute value of our b value. And we know our b because there is no c value, so there's no horizontal phase shift going on. But our b value then is just 1/2. If there was a horizontal phase shift, we would have to factor out that b. So what color? I used pink. We could mention our c equals 0. So now that we know our b is equal to 1/2, we can plug that in order to compute what the period is. 2 pi divided by 1/2. And when we keep change flip, we end up getting 4 pi. No, actually, I'll use a different color to represent the period itself. Why don't we use blue? Because B is light pink, blue is our period. And we're done. Any questions on this one? So finally, we're at our question 4, which we'll have to once again calculate amplitude and period so that we can properly graph it. It's just now we're dealing with a different function. So our function here is f of x is equal to, and I like to put that vertical shift last, just like we see it in our general equation of trigonometric functions and their transformations. And so now let's calculate our amplitude. Our amplitude is just that absolute value of the leading coefficient, which is 1 in this case. So A is equal to absolute value of 1, which is 1. Our period is 2 pi over B. Once again, we have no horizontal phase shift going on. So our B value is just 4 pi, which means if we plug this in, and it's absolute value of B in the denominator, we get 2 pi divided by the absolute value of 4 pi, which is just positive 4 pi. And then the pi's cancel out, and then 2 over 4 can be simplified to just your period being 1/2. And so let's just take a moment to recall what period means. This tells us that every 1/2 interval, we have a full cycle taking place within our function. So we have a representation of a minimum value taking place as well as a maximum value taking place. And then our function intersecting through our midline, which brings us to our next point. What is our midline here? Well, our midline is the same as our vertical shift, which is D. And so our midline is just y equals -2. So we can actually go ahead and plot this midline right now. Lucky for us, I created the scale for you guys to save you some time on the quiz. You just needed to put in your X and Y axis and then the origin. And so let us plot this horizontal line at -2. I'm gonna create it as a dashed line. So we have it over here. Don't forget to label it. Right? And then now let's just take a moment to think about cosine. We know sine x hits through the origin, but cosine at our y-axis actually starts at 1. And more specifically, what is our range of both sine and cosine functions? Just the parent function. So sine of x and cosine of x has a range of what? From, it's your lowest possible y value, negative. And what's your highest possible y value? Positive. Exactly. Good. So if that doesn't include any transformations, now we look at how we have this vertical transformation down to, what does that tell us? What's our new minimum value? If our previous was -1, but now we're bringing it down another 2 units, our new minimum is at -3. Okay, what's our new maximum? Be careful. Our original maximum was 1, but we shifted the whole graph down 2 units. So what's 1 minus 2? Exactly. So we have our absolute max at our -1 and our absolute minimum values at -3. Okay. We did all of this information. we identify the amplitude, we identify the period. Let's write that down. Our amplitude is 1, our period is 1/2. Now let's graph it out. Let's choose some really good points so that we can create our sketch of this graph. And so again, keep in mind that our period, our full cycle happens every half interval. So what are some good points that we should probably choose? We should choose 0. Let's choose between 0 and 1/4, which is 1/8, 1/4, between 1/4 and 1/2, which is, what is it? Yes, thank you. 3/8, and then 1/2. So we have 0, 1/8, 1/4, 3/8, and then 1/2. And then from there, you'll be able to figure out new points. And if we have to add more, we can always add more. So if we plug in 0 for x, what's inside our parentheses just shoots to 0. And so now we're looking at cosine of 0. And what's cosine of 0? Yep, subtract 2 from it, and what do we get? -1. Now let's look at 1/8, and I think instead of moving up and down, I'm just going to write the function again. So we have cosine 4 pi x minus 2. So y is equal to cosine 4 pi x minus 2. Okay. So now let's plug in 1/8 for x, which makes us looking at cosine of pi over 2. And what's cosine of pi over 2? 0. 0 minus 2 gives you -2. Now, if we plug in 1/4, we're looking at cosine of pi, and cosine of pi gives you -1. Minus 2 gives us that absolute minimum at -3. Let's plug in 3/8, and so we get 12 over 8 pi, which simplifies to 6 over 4, 3 pi over 2, aka 270 degrees, which makes our cosine once again 0. Minus 2, you get -2. And then we have 1/2 plugged in, so we're looking at cosine of 2 pi, which is just once again 1. And then we have 1 minus 2, which gives us -1. So now let's just plot these points. So 0, -1, 1/8, -2, 1/4, -3, 3/8, -2, and then 1/2, -1. And so this is one period. So essentially now this is just being repeated. So we can just add in our additional dots based off of just the placement of our previous ones. You don't have to really do any calculations anymore. And you also don't have to do all of these dots, but I'm just doing it so you can really see it. Okay. I just want to make sure I did that one correctly. Good, good, good. Yeah. Why does this one look a little off? Okay, 1, 2. That's why. 1, 2. Okay, so now let's just connect the dots. So we have and then don't forget your arrows. And then we labeled it over here. Maybe I'll put this in purple so you know that. I labeled it. And there we have it. This is our graphed function of cosine 4 pi x minus 2. So that completes the quiz.